Finding critical numbers of a function that is a fraction can be kind of tricky. Chances are there's probably just one specific thing that you're forgetting to check for though, or that's tripping you up if this is something you have a hard time with. And in this video, I'm going to show you exactly what that one thing is. I'm going to be showing you with an example that I have from one of my weekly live stream videos that I do every Monday night at 5 o'clock Pacific time, where we took a function which was a fraction. In this specific example, we had a fraction that was a rational function. So if you're looking for how to find critical numbers of a rational function, this is going to be a great example for you too. And this trick that I'm going to be going over is actually going to be something that really comes up a lot when you're finding critical numbers of different types of functions. So it's not just applicable to fractions or rational functions. So I think you're going to get a lot of value out of this video. If that sounds good to you, be sure to stick around to the end of the video. I'll be showing you how you can apply this trick and how you can find the critical numbers of a fraction, rational function, or a handful of other different types of functions that this would be applicable to as well. Anyway, let's go ahead and jump into the example and I'll show you what I'm talking about. Find the critical numbers of the function. In this example, we have h of p, our function h of p equals p minus 1 all over p squared plus 4. Okay, so again, to find the critical numbers, we are always going to want to consider the same two things. Where does the derivative of your function equal 0? Where does the derivative of your function not exist? Those are always going to be the two conditions that create critical numbers. So you just need to figure out what p-values make that happen. Before we get into this example, I do want to just throw out one thing. If you are getting some value out of this video, please do me a favor and hit that like button down below. If you appreciate me coming on and doing this this version of this video, even though I wasn't available for a live stream this week, hit that like button. Huge help to my channel. So anyway, thank you for that. Let's go ahead and jump back into the scheduled programming. So first step is going to be to find h prime of t. We need to find the derivative. Finding the derivative of this function is just going to use the quotient rule. Quotient rule just says that we're going to call the numerator of our function f, the denominator g. We then need to find f prime and g prime. So the derivative of the top of our function, the derivative of p minus 1 is just 1. And then the derivative of p squared plus 4 is going to be 2p. And that's just based on the power rule. Okay. So then quotient rule says you're going to take, to find the derivative of your function, you're just going to take low d high. So low times the derivative of the high, the bottom of your fraction times the derivative of the top. So p squared plus 4 times 1, which is just p squared plus 4, minus high d low, so minus f times g prime, minus high d low, p minus 1 times 2p. And make sure you do put these in parentheses because this minus sign is going to need to distribute to all this stuff. Okay, then that's all going to be over the bottom of your fraction squared. So let's think, before we go ahead and continue with simplifying this, let's think about these two conditions here and this derivative we found here. So this derivative is the derivative of our function. We could definitely simplify it, but before we do that, let's think about this. What would cause a fraction like this to equal 0, right? We want to figure out where h prime equals 0. Here's h prime, this fraction. Where does it equal 0? Well, it's going to equal 0 wherever the numerator of your fraction equals 0, right? 0 over anything is 0. So really, to satisfy this first condition, we just need to figure out where the numerator of our fraction equals 0, okay? Where is a fraction not going to exist? A fraction does not exist when the denominator equals 0, right? So if the denominator equals 0, then you're getting some number divided by 0. Well, that basically breaks a rule of math. You can't divide by 0. That's not a thing you can do. So if you're ever dividing by 0, if your denominator ever equals 0, then your function does not exist there. So we need to figure out where our denominator equals 0. If either of these two things happen, then one of these two conditions will be met, and that tells us that that p-value is a critical number. So basically, these are the two equations we needed to solve to find the critical numbers of our original function h of p. So let's go ahead and think about how to solve these equations. Let's just go ahead and kind of distribute this out over here and simplify this. So we'll leave our p squared plus 4 alone for a minute. The 2p will multiply into both of these terms here. So we're going to get 2p times p is 2p squared. Minus 1 times 2p is minus 2p. Then we need to distribute our negative sign in here. So that's going to be p squared plus 4 minus 2p squared plus 2p. Okay, then we can combine our negative 2p squared and our positive p squared, giving us negative p squared plus 2p plus 4 equals 0. And then we would want to see if we can factor this out, which I don't think we're going to be able to factor that out. It's not going to factor nicely in this case. No, it's not going to work out very nicely. So what we can do is use the quadratic equation. So p is going to equal the opposite of lowercase b plus or minus the square root of b squared minus 4ac all over 2a. Oops. In this case, a is negative 1. And then from there, we would want to basically solve that out. So negative 2 plus or minus the square root of 4. These negatives here are going to cancel. So we're going to get plus 4 times 1 times 4 is 16. So 4 plus 16 is 20. All over negative 2. So let's see here. We can kind of factor out a 4 out of this, giving us negative 2 plus or minus 2, because when you factor a 4 out of a square root, you have to square root it, leaving you with 2 times the square root of 5 all over negative 2, which then is going to simplify down to basically this negative can kind of cancel with all these. So we get, and then the 2 is going to cancel with all these, turning all of them into a 1. So we get 1 plus or minus the square root of 5 all over 1. So 1 plus root 5 and 1 minus root 5 are 2 of our critical numbers. Then we just need to solve this equation. So if we square root both sides, we get p squared plus 4 equals the square root of 0, which is just 0. And then we minus 4 from both sides. P squared equals negative 4. Square root. Well, you can't square root a negative. So this equation, actually, there's not going to be any p values that cause our denominator to equal 0. And so as a result, there's no p values where h prime of p does not exist. So we're just going to have these 2 critical numbers from the p values that make h prime of p equal 0. So this is going to be our final answer, just these 2 critical numbers here. Well, I hope you found that video helpful, and you can keep those 2 pieces of finding critical numbers in the back of your head as you work through other examples. Because like I said, they are going to be helpful in lots of other examples. If you want to keep this brain train rolling and keep on learning about calculus, just go ahead and click on one of those videos over there. And if you want to join for my weekly live stream, it's every Monday night at 5 o'clock Pacific time. Hit that subscribe button and that bell icon so you're notified when I'm going live, and I hope to see you there.